Hi everyone, my name is Jie. So now you are watching a video made by me of showing you how our math group is planning to teach the Pythagorean Theorem to 8th grade students. So the members in the math groups include me, Jen, Kennedy, Patrick, and Nam. So the lesson plan model we picked is 5E. So let's get started. So, at the beginning of the lesson, I'm going to start by saying, hi class. So if you hear me, clap once. If you hear me again, clap twice. Then I will scan the room, make sure I get everybody's attention. Then I will say, so today we're going to start the lesson by working on a very interesting real life problem. So you're going to work with a table partner and you're going to have 1 minute to work on the activity. So if you don't have a partner, please come and see me. While I was talking, I will walk around the room and pass the materials to every single group. So this is a material each group is going to receive. And then, so for students who need accommodations, they're going to receive the materials with the same content, but it will be represented in different ways. Like this is a version for students with dyslexia. So as you notice, like the fonts are in the larger size here, and also the keywords are highlighted. And this is a copy for ELL students. So all the keywords are highlighted. Okay. So I will say, first I will find someone. I will randomly pick a student to read the question for the class. So I'll say, today we're going to use a very different way to randomly call on students. So as you can see, I have a cup here, and also I have like sticks inside the cup. So on the sticks, I have everybody's name written on it. So I'm going to draw a stick, and if your name is on the stick, you're going to be the one who is doing the assignment or answer the question. So after you are done, and then I will just leave the stick on the side, so that way, so the rest of the students will have a better chance to be called on for the next assignment. Okay? So for the first assignment is to read the question for the whole class. The person I picked is student C. So would you please stand up and read the question for the whole class, and then I will put the stick on the side. Okay, after students finish reading the question for the whole class, I am going to explain the question again for the whole class. So the way how I do it is I'm going to put this worksheet on the projector so everybody can see. And I will say, okay, so here, in the question it says, Lucy went yearly from her house to the park. She takes Silver Street first, and then she takes Maple Avenue. But today she wants to try something different. So there are 3 routes she can choose from, A and B and C. I want you to talk to your table partner to find which route is the shortest and why. So if you feel you need some tools to help you to figure out the solution, so you can come to the front. So I have scissors and a string you can use. Of course, you can talk to your group to decide how you can use the tools to help you to help you with your discussion. Okay. So then I will ask specific questions to make sure students understand what they're supposed to do. I'll ask how long the activity is. So they will say 1 minute, and then I will say, what are you expected to do? They will say to find the shortest route. And then I will say, any other questions? After I make sure everybody knows what to do, I'll say time starts now. So when students are working on the activity, I will walk around the room to do some carry on some personal conversations with students, such as how was your day, how was your weekend, something like that, and also to make sure every student's on task, and also to help them if they have questions. Okay, and when there are 20 seconds left, I'll remind the student by saying 20 seconds left, so please wrap up with your discussion. So after the discussion is done, so I will randomly pick one student to share their discovery with the rest of the class. So, and then I will repeat the same procedure for 2 more students. So after they have finished the sharing with the thinkings, I'll say, thank you all for sharing your thinking. So I definitely agree with you that the shortest distance between the 2 points is the straight line. Okay, now I have one more question for you. Okay, so after you figure out the shortest distance is the straight line, how can we figure out how long the distance is? Okay, then I will say you talk to your same partner, and you have 30 seconds to discuss the question. So while I was talking, I will walk around the room again to pass materials. So this is going to be the materials each group is receiving. Again, for students needs accommodations, they're going to receive different materials. This is for EIL students. So the keywords are highlighted. And this is a version for a copy for students with dyslexia. So again, the fonts are in the larger size, and also keywords are highlighted. Okay, so students, after the 30 seconds discussion, okay, then I will suggest students, okay, so students, high class, if you need help, you can come up to the front to grab a ruler to help you get the measurements of the 3 sides. Okay, and after you get the measurements, so please write down all the 3 numbers on your handout. Okay, so you are going to have 1 minute to work on this activity. So then I will double check with the students if they know what they're supposed to do. Okay, I'll ask how long the activity is. Student will answer 1 minute, and what are you supposed to do? To measure the distance and write down the numbers on the handout. And then I'll ask any other questions. So when students start working on the activity, I will walk around the room again to make sure everybody are on task, and also to help them if they have any questions. This is how their handout would look like when they finish the measurements. Yeah, to make it simple, so instead of call Silver Street, I will just put A here, Maple Street a B, and the straight line put C. So the A is 3, B is 4, and C is 5, right? This is supposed to how it looks like. But I will random call on students again to let the students share their measurements. Okay, I will say, yeah, please share your measurements. Then I will double check with the whole class and ask, so if every group get the same measurements, like 3, 4, and 5, after I get the answer yes, I'll keep asking. So now the question is, can we come up with a solution, like equation, to include the 3 numbers in? So you can use either plus or minus or multiplies or times or divided, or like square roots or equal or something. Anything, any symbols you can think of, operations you can think about to include the numbers 3, 4, and 5. Okay, so talk with the same group partner for 1 minute, see if you can come up with something. So when students are talking, so I will be walking around the room to make sure everybody are on task. After time is up, so I guess the students will say, oh, hi miss, so it's so hard, we cannot really think about anything. Then I'll say, yeah, I understand, because I cannot find a solution either. So let's work on an activity to see whether we can figure out a solution. So in this case, so instead of directly giving students the equation of Pythagorean Theorem, so I will let them to work on activity to figure out the equation by themselves. So this is how the materials, activity materials would look like. So this time, so I will first say, hi class, so I want you to stand up, and instead of working with a same table partner, I want you to stand up and find someone who is not in your table, okay? And to form a new group, and you're going to with a new group partner to work on the following activities. By introducing this physical transition here, so student will have a chance to stand up and walk around the room. Yeah, so it will better help them to get engaged. So that way, when they're like spending time finding a new partner, so I will pass the materials to every single table. So I also asked, so if you don't have a partner, please come and see me. So after I notice everybody gets a new partner, okay, I will say, now everybody have a new partner, right? Okay, so on each table, you will find our zipper bag. So in this zipper bag, if you open it, you're going to see 4 pieces of pre-cut sheets. Okay, so you have a triangle and you have 3 squares of different sizes. So the first thing I want you to do is to put the triangle in the center of your table. And then for the 3 squares, each square has a side, so which is the same size, same measurements as one side of the triangle. I want you to first find the match. For example, for the yellow one, which is smallest square, so we can compare. This is not a match, and this is definitely a good match. So I want you to do the same thing with the rest for the other 2 squares. So you will have 30 seconds to work on this activity. Okay, so when students are working on the activity, I will just walk around to check if everybody are on task. So after time is up, okay, I will call on the students to the front of the desk and to show how they do their arrangements of the 1 triangle and the 3 squares. So when they're doing it on the projector, so everybody in the class will be able to see. And then I will ask, so if every group come up with the same arrangement, after I get the answer yes, so I will ask them the second question. So now I have one more question for you. Can you figure out the areas for every single squares, the 3 squares here? After 5 seconds of wait time, I will use a yellow square as an example. See this yellow square? We know it has exactly same length of side as the smallest side of the triangle. So the side is A, so the area of the square is A square, right? So what about the other 2 squares? Can you figure them out? So students, so you will have 30 seconds to do that. So after 30 seconds, so students will be able to find out this one is B square and this one is C square. Okay, then, I will ask the students to discuss their experience. Oh no, I'm sorry. Then the next thing to do is I will ask the students to use a scissor to cut the blue square along the lines. And then the next thing for them to do is after they cut it, so they're going to play with the 4 parts of the blue square and this yellow square. See whether they can fit all the 5 things together inside this big purple square like a puzzle. So I'll say, so you're going to work with 4 pieces of parts of the blue square and the yellow square, and let's see if you can fit everything inside the purple square like a puzzle. So you're going to have 1 minute to do the activity. Then I will ask specific question to double check if they understand. So I will say how long the activity is, and then what are you supposed to do? The last question would be any other questions? After every student know what they need to do, I will say a time starts now. So when students are doing the activity, I will just walk around the room. And then I will, when time is almost up, when 20 seconds left, I will say, there are 20 seconds left, so please wrap up. So after students finish their activity, so I will randomly pick a student to come to the front and to show their work on the projector. So this is how it's supposed to look like when they finish the work. Okay. So since the work will be showing on the projector, so every student in the class will be able to see. Okay, so it would look like this. And then I will ask students to discuss their learning activity experience in working on the activities by answering several questions. I'll say, so hi class, what you did, congratulations, you did a very interesting activity just now. Every group worked so well. So let's try to answer some questions to share your experience of working on the activity. So the first question to answer is, what did you do in the activity? So I want you to talk to your partner about this. And the second question would be, what did you discover when you're working on the activity? So in order to help all students understand what question they need to answer, I'm going to either write those questions on the whiteboard, or I'm going to show the two questions by using the projector. Okay, so all students, including the ELL students, will be able to follow. After you will have I will let students know you will have 1 minute to talk about it. Then I will just randomly pick two students to share, draw two students to share their experience. So after that, I will ask them one more question. So it would be, so students, can you use an equation to express your discovery? Since you already know you are able to fit everything inside the big square as a puzzle. Okay, so I will just guide the students. See, like the smallest square is the area is A2, and the four parts of the blue square, so if you put them all together, the area is B2, right? For the largest, the purple one is C2. That means A squared plus B squared is equal to C squared. And remember the triangle we worked with at the beginning? So that's A is the side of the A, B, C are all sides of the three sides of the triangle. So which means A squared plus B squared equal to C squared. Okay, so that's the equation, right? So then I will ask students to answer one more question. So can you express your discovery by using mathematical vocabulary? So I'm going to write this sentence stamp on board. So here are all blanks. So students will discuss and see what the words in the mathematical vocabulary they are going to put into the blanks. So here would be how it looks like. So the sum, right, this is sum because they have the plus sign, it's the sum. Squares of the lenses, that's the lenses. That's not anything about angle, right? So it's the lenses of the legs, that's the two legs, right? It's equal to the square of the lenses of the hypotenuse. That's a hypotenuse. Here I will say, congratulations every group, every student. So you figure out the equation, you figure out the definition of the Pythagorean theorem. So it's going to be the first time the term Pythagorean theorem is introduced in the class. Then I'll say, so this theorem is named after a Greek mathematician whose name is Pythagoras. Then I will ask students to stand up and to come back to their original seat. So when students like spending time stand up and walk back to their seat, I'm going to walk around the room to pass more materials. Okay. So this is the materials I'm going to pass to every person, because instead of to each group, this is a worksheet everybody is supposed to be asked to complete and glue this to their math journal. So everybody is going to have a copy. So this is like most of people receive, how it look like. And this is a special version for ELL students, because I'm going to provide the like sentence stamp, so it will help them to fill in the information instead of like the big like blocks for them to put in the whole sentence. For students with dyslexia and for students with anxiety, so the handouts already has been sent to them one day before. So that way they can get familiar about the materials early. And also the students with dyslexia, they're encouraged to use their device. So the applications like the Word application on their device, they can use a spelling checking and also grammar checking to help them take the notes. Okay, so that will be more easier for them. Okay, so in this case, I'll say, so now everybody, so you receive our handout. Okay, I want you to finish the handout. But before that, I'm going to show you a very interesting video about many important and interesting facts of Pythagorean theorem. So by watching the video, you will learn a lot, and the information will help you. The information you learn from watching the video will help you to complete this worksheet. So before you watch the video, so I want you to take maybe like 20 seconds to go through the questions very quickly. So don't worry about the last two questions. They are both about the applications. So I want you to only focus on the questions on the left side of the worksheets. Okay? So after the 20 seconds, I'll start play the video. So the video is about 3 minutes long. Okay, so here is the link. This is how it looks like. So this is about like how Pythagorean theorem is applied in real life.
A receiver or running back making a beeline for the end zone with a defender in hot pursuit.
In NFL.
From there, you want to close the distance between yourself and the ball carrier as quickly as possible.
Yeah, this is how the Pythagorean theorem is applied in real life. I was just, in order to save time, I just quickly go over.
Called a right triangle.
Right triangle.
On a right triangle, the two adjacent sides, A and B, are called the legs. The longer side, opposite the right angle, C, is called the hypotenuse. The Pythagorean theorem simply states a squared plus b squared equals c squared.
The square of
it talks about this equation. Yeah, and somewhere in this video, it also talks about
take the square root.
How to apply this,
plus 30,
the theorem, and it's also somewhere in the video it talks about the Pythagoras. So after students watch the video, there will be, so I will give them like 2 minutes to work on the worksheet, to work on the handout. So I will say, okay, you will have 2 minutes to talk to your table partner to complete the worksheets. So after to complete the handouts, okay, so when they're doing the discussion, so I will walk around the room and give this copy to my ELL students, so with all the keywords listed, so it will help her to discuss the definition and explanation of the Pythagorean theorem. Okay, so after the discussion are done, so I will show my handout on the projector, and then I'll explain the question one by one to make sure everybody understands. So I'll read, for example, I'll read like the first question. The Pythagorean theorem is for finding the side lengths of right triangles. So here I'll emphasize it's to find the length. It's nothing about the angle. It not like the theory can only be applied for right triangle, not for any kind of triangles. And the second question is about the Pythagoras. Who is Pythagoras? So he is a Greek mathematician and philosopher. And here is a review of what they did in the activity and how they come up with the solution. So this is how you come up with the solution, student. And here I want to make sure they really understand what each letter in the equation stands for. Like A and B stands for leg, and C stands for hypotenuse. Okay, lastly, I want to emphasize again, it only applies for right triangles. Okay, so after students finished everything, so I'll say, hi class, I want you to lift your right hands, okay, which means what we did just now, we just learned how to the definition and the equation of the Pythagorean theorem. And let's raise your right hand. What about the application of the theorem? So are you curious about it? Yes. So we want to put the two hands together, which means we're now in this session we're going to extend what we learned just now to how to apply the Pythagorean theorem to solve problems. Okay, so if I will ask the students to look at the right side of their handouts. So I'll tell students first, we will start with the first question. Then I will random pick a student to read the question for the whole class. After students finish reading, I will point out the keywords, so which is leg and hypotenuse. So then I will ask students, do they still remember the equation? To check the left side of the handout, that's a squared plus b squared is equal to c squared. AB stands for leg, and C stands for hypotenuse. So in this case, they know which number to plug into the equation. So I write the equation on the board so everybody can follow. So then I will ask, anybody are good with me now? So you know how to do this question? So after everybody say yes, I will move on to the second example. So what I'm going to say is, so I want you to look at the second question to tell me what's the difference between the example 1 and example 2. So students will randomly answer me, say, oh, the first question is a word problem, the second question you only see figure. And then the other thing is, I will ask what's more. The students may come up with something like, oh, because this one you know the A and B, you try to figure out C, and this one you know C and B, you try to figure out A. Yeah, that is a difference, right? So we're using the inverse of the Pythagorean theorem to solve the problem. So I'll ask students to talk with a group partner and to come up with a solution. I'll say, you will have 1 minute to figure out the solution for this one. So when they're working on the question, I will walk around the room to see if everybody are on task, and to help them with the questions and to check whether they get the right solution. After that, I will just ask one student to come to the front to write their answer on the whiteboard so everybody can see. Then I will just explain the steps, the procedure step by step to make sure everybody understand. So after that, I will say, okay, so students, you'll have like 30 seconds. You'll have 30 seconds to complete your handout. So after you complete your handouts, I want you to glue your handout to your math journal on page. Okay, depends on like where they put their previous handout on the journal. So I know which page you're supposed to put this one. Okay, I'll let them know. So that way everybody can easily track each handout when they need to. After that, okay, so when students are gluing the handouts to their journal, I will walk around the room and pass materials, okay, to each table. Okay, so then after I will say, okay, if you're done with gluing, okay, you're done with your journal, so please put your hands on the table so I will know, okay? So when I notice everybody are finished with their handout, so I will say, so now we just learned how to apply the Pythagorean Theorem and its inverse to solve problems, right? So now you're going to have more practice, even more interesting practice. So everybody on your group, you see a pennant like this, okay? So this is the copy ELL students is going to receive. Okay, I highlighted every keywords, okay? So I will use this copy to explain what they're supposed to do. So as you can see, this is a pennant. So you try to figure out this. So does it kind of remind you something? Yeah, this is the same thing as you did in the previous activity with the triangle in the middle and the 3 squares of the different size on the side, right? So like for this one, for example, you know the small triangle, a small square, the area is 9, you try to figure out the side is 3. And then for this one, the area is 16, so the side is 4. So you know 3 and 4, and you know this is a right triangle, so you will be able to use the Pythagorean Theorem. So you will be able to figure out, oh, the length here, the hypotenuse is 5. So that's where you're supposed to write 5. And the last question for the triangle, about the triangle, is to find the perimeter of this one, of the triangle. So if you know the 3 sides are 3, 4, and 5, when you add them together, it's 12. That's a number you're supposed to put in the middle, right? So for each group, you're receiving different pennant. So it asks you to do different things. But overall, you're going to use the Pythagorean Theorem and use your previous knowledge about areas and parameters. So that way you are able to solve this pennant, the calculation. And also one more thing is, as you can see, everything is in black and white. After you're done, I want you to do a coloring each pennant. Okay, at the end, after you turn in your work, I'm going to like hand everything inside our classroom to celebrate your mastery of the Pythagorean Theorem. Okay, so if you need like colored pencil, you can come to the front to grab some, okay, at the end. So when you finish your work, it's going to look like this when everything is handed in the classroom. Okay, so you are going to have 3 minutes to work on this activity with your group, okay? So when students are working on the activity, before they start working on the activity, I will ask a specific question to make sure they understand. So I will ask how long the activity is and what are you expected to do, and then I'll say any other questions. When they started doing the activity, I will just walk around and make sure everybody are on task, and also to help them if they have questions. Yeah, I will also walk to the ELL student, make sure she understands the definition of each question, and to remind her to use the list of the keywords. Okay, when there's 30 seconds left, I will say 30 seconds left, please wrap up with your work. Okay, after they finish the work and turn in the work, I will say, so everybody, congratulations for completing a very interesting activity. So then I will ask a question. So after you watch the video and studied how to apply the Pythagorean theorem to solve problems, do you think it's important to learn the Pythagorean theorem and why? And you will have 1 minute to discuss with your group. So after time is up, I will just call on 2 or 3 students to share their thinking. Then I will conclude the discussion by saying, I agree with all of you that it is important to learn the Pythagorean theorem because there are so many uses of the Pythagorean theorem. For example, if you know the lenses of the 3 sides of the triangle, you will be able to decide if the triangle is, whether it's a right triangle by using the Pythagorean theorem. And also, if you know the lenses of 2 sides of a right triangle, you will be able to figure out the lenses of the 3rd side by using the Pythagorean or its inverse. In addition, there are so many like real-life applications of the Pythagorean theorem, and the video, the NFL video we just watched, is a very good example of that. After the discussion, so students will move to the evaluation part of the lesson. Okay, so I will say, hi class, so eyes on me. So students will say back, eyes on you. So I will scan the room to make sure I'll get everybody's attention. I'll say, so in the next 15 minutes, so every student, you're going to work on evaluation worksheets. So there are 5 questions on the worksheet. So I will just briefly explain what you need to do. Like for the first question is about how you understand the Pythagorean theorem. Remember what's the important things you need to remember to understand about this. Like, is it about length or about angles? Or is this a theorem can be applied for all kinds of triangles? Remember to mention about all those key points in your explanation. And the question 2 and 3 are about how to apply the Pythagorean theorem and inverse or its inverse to solve problem. And the next 2 questions are word problems. Okay, it's also about applications of the Pythagorean theorems. So this is a version everybody is going to receive except for ELL students. So EL student will receive a different version with all the keywords listed. And also when the student is working on the worksheet, I will walk to her to make sure she understands the questions. If she needs help, I can explain it to her, like in the simpler language, or rephrase the question. So for students with dyslexia and anxiety, so they already received the evaluation sheets. They are going to receive For the students with dyslexia, she's going to receive the evaluation worksheets in electronic copy. So she will be able to use the programs like applications on her device to help her work on the worksheets. And the students with anxiety, so he is going to receive a worksheet like this, but he doesn't have like a time limit, like for how long he's supposed to have it done. He can take the worksheet home to have it done. Okay, so when students are working on the worksheet, so I'm going to sit on next to my table to prepare the materials and handouts for the next lesson. So some of the students, they may finish the worksheets earlier than other students. So if they're interested, I'm going to hand them like additional question to work with, such as like whether the straight line is always the shortest route between the 2 points and why. So this question is about to help students to understand. This is only applies for a flat surface. So when it's about like, when it's a globe, so it's not always the case, right? And the second question is a like extension of the application we learned, because for the questions we learn here, so I already told students this is a right triangle. But if I give them a three-dimensional structure shape, so they need to first figure out this is a right triangle before they can apply the Pythagorean theorem. Okay, so after when there's like 1 or 2 minutes left, I'll remind students there is 1 minute left, so please wrap up. After you finish, please turn in your worksheets, okay? And then at the end, so I will get students' attention again by saying, if you hear me, clap once. And then I will say, if you hear me again, clap twice. Then I will scan the room, make sure everybody is looking at me. Then I will say, okay, so today in our lesson, we worked on several hands-on activities. And by doing that, we figure out the equation and the definition